Okay, because this is a hydrocarbon, it means there's only carbon and hydrogen in it, and if there's 84% carbon, it means there's 16% hydrogen. If we know the percentage composition of it, we can say how many grams of each would be in a 100 gram sample. From that information, we can work out the number of moles in 100 grams. So in a 100 gram sample, there are 7 moles of carbon present and 16 moles of hydrogen. The simple cell number ratio for those two numbers is just 7 to 16. So your empirical formula is going to be C7H16. And when we look at the alternatives, that is alternative D. Now in this question, we've got 6.35 grams of copper. And the first thing in any calculation you do is work out the number of moles, whatever you can. And so we can determine that there is 0.1 of a mole of copper in the original thing that was dissolved in the nitric acid. Now that 0.1 of a mole of copper is producing producing copper hydroxide, but for every 0.1 mole of copper, you're going to get 0.1 mole of copper hydroxide. And then that copper hydroxide was converted to copper oxide, and again, for every 0.1 mole of copper hydroxide, you would get 0.1 mole of copper oxide, because copper only appears once in each one. When you use that number of moles of copper oxide to work out its actual mass by doing the number of moles times the molar mass, you get the actual mass of copper oxide would be 7.95, which is going to be answer B. So in this question we've got 355 grams of iron, so we're going to use that number to work out how many moles of iron there are. From that we determine that there's 6.36 moles of iron in that sample. Now the question is asking how many moles of hematite are in that sample that contains that much iron. And we know that 1 mole of Fe2O3 will contain 2 moles of iron. And we've got to answer is how many moles of Fe2O3 would contain 6.36 moles of iron. And the answer is it'll contain half of 6.36, which is 3.18 mole. And 3.18 mole is going to give you answer D.